Hi Year 12 Maths General students. Today's lesson is from Unit 4 of the Queensland General Maths program, and we're looking at investigating amortisation with the help of Excel, which is looking at reducing loan repayment schedules, and as part of that we're looking at how to save a bit of money. So the lesson objectives today is using recursion models as well as Excel. We're going to investigate loan repayment schedules or amortisation and calculate the money saved by making either higher repayment amounts, making lump sum repayments, or by choosing lower interest loans. Any one or a combination of these things can help you save a lot of money. The process of paying off a loan using regular payments over time is known as amortisation, which cover paying off both your principal borrowed and interest that gets applied by the financial institution during the loan period. When you take out a loan with some sort of financial institution, it's common that you'll receive a loan repayment schedule from the financial institution, so you can track what's happening with your payments. I'm going to look at an example that I've made up where I'm showing you a typical repayment schedule that you might see from a financial institution. And this one is based on the first 5 months of paying back a bank loan of $250,000 that's been taken over 30 years at an interest rate of 4.12% per annum, compounding monthly. And the financial institutions told you that you've got to make monthly repayments of $1,210.90. And you can see here this loan repayment schedule has the month or repayment number first. You'll notice that the repayment amounts are the same. Of that repayment amount, it then breaks up how much of that repayment pays back interest, how much of that repayment pays back your principal, and then the last column looks at what is the balance of your loan. So what I'd like you to notice is over the 30 years, which if you look at how many months that is, that's 360 months. As we progress through the loan repayment schedule, you'll notice that the repayment amount will stay the same. The interest you're paying the financial institution will decrease over time as you're making more repayments. The principal reduction, so how much you're paying off the original amount you borrowed, will slowly increase over time. And the balance of the loan that you owe the financial institution will decrease over time. And if you were to graph your typical reducing balance loan, it would look something like this. For this particular loan, you can see that we started off with $250,000, and slowly we have this exponential decay, which is a non-linear type function, as the loan balance reduces until you get to that 360th or final repayment. Just a quick refresher, the recursion formula is on your formula sheet for reducing balance loans. So just remember that this gives us our next consecutive balance is equal to the interest applied on the loan multiplied by the previous balance, and we subtract our repayment value. We also looked at how to calculate the total interest paid after a certain number of compounding periods n after the loan began. And to do this, we took the balance of the loan after a particular number of compounding periods, we minus the principal, and we added on the total amount of repayments that have been made. For the purposes of calculating interest for each of the loan repayment periods, we're going to slightly modify this formula. To work out the interest for that particular repayment period, we find the difference between the two balances and we add on the repayment amount. The next thing we need to work out is the principal reduction, and that's really easy to find. All we need to do is take the repayment amount and subtract the interest for that particular repayment period. So if we come back to the repayment schedule I had up there for that $250,000 loan, to work out this first repayment period, we know that the repayment amount is $1,210.90. So that's where that value comes from. The next thing we would work out is the balance remaining after we've made that repayment. To do that, we simply use the recursion formula, and I needed to work out that rate, which was 1 plus the interest over 100 times the K value, where the K value was 12 because there's 12 months. So that gives us a rate, and this is a rounded rate. You have to be very careful of using these in your calculator. And we have 1.00343, which gets applied in our recursion formula for a reducing loan balance to the original 250,000 minus the repayment amount. And that gives us the balance after month 1 of $249,647.44. So that's where that value comes from. Okay, next we would work out the interest paid. So to do this, we simply take the difference between the initial 250,000 and the balance after month 1, and we add on the one repayment of $1,210.90, and that gives us the amount of interest that has been charged for that particular period, which is $858.34. This leaves us with just the principal reduction to calculate. So to do this, we simply take the repayment value of $1,210.90 and we subtract the interest paid off for that particular repayment period, and we get $352.56, which matches what we have here. So if we had to work out a repayment schedule for the first couple of months or the first couple of repayments, depending on how often you have to repay them, the first thing I would be putting in is the repayment. The second thing I would work out is the balance column on the loan. And remember, that's simply using the given recursion formula for reducing balances. The third thing I would work out is the interest paid. And remember, that's just taking the difference between the two balances and adding on the repayment amount. And then lastly, I would work out the principal reduction, which is simply the repayment amount minus the interest that you've paid back the financial institution for that particular repayment period. Now, if we had to do that for every single one of those 360 payments, we'd be there forever. So luckily these days we have technology to help us see this. What I'd like you to do is open up this Excel spreadsheet. This is a great way for very quickly doing all of these calculations for us, and it can also help us visualize how making extra repayments, lump sum repayments, or shopping around for a lower interest rate can save us a heck of a lot of money. So when you open it up, the first thing you'll see is this loan data on the left hand side here. This is where we input all of our loan details. Over the right here, we've got a loan summary. This is a great way of calculating things like when will we pay the loan off, what's the total interest we've paid the financial institution, what was the principal, did we manage to pay any extra principal off faster during the loan, and in green here, how much did you pay in total over the period of the loan to the bank. And I've added in a couple of extra things here. I found this amazing spreadsheet on this site, tvmcalcs.com, and big shout out to Timothy Mayers for creating this. And he has very kindly allowed anyone to download and use this program. So for those watching, I highly recommend using it to help understand amortization. I have included a copy of this spreadsheet in the description below this video. Okay, we're going to use a spreadsheet to work through an example considering this loan that we looked at initially of $250,000 taken over 30 years at 4.12% per annum. Compounding monthly, where required repayments are $1,210.90. So using the spreadsheet, so we'll open it back up in a second. How much is paid to the bank over the duration of the loan, and what amount of this was interest payment? Secondly, we're going to look at if we were to make extra repayments of $50 a month, what would be the effect on the loan and potential savings? If I then change it back to the original loan details, what happens if I put in a lump sum repayment of $5,000? And what I'm going to do is put it in a different time periods during the loan to see if that makes a difference on how much we save. And then lastly, we're going to compare it to another loan institution that's offering a lower interest rate and see the effects on potential savings there. Okay, so I've just ensured that each one of my inputs is correct. So the $250,000, 30 years, 4.12%. The K value is 12, so monthly, and it gives us a payment amount of $1,210.09. To answer part A, the total payments that we would make over the period of that 30 years or 360 months would be $435,923.35. So you can see that over that 30-year period, we've paid back the bank $185,923.35 in interest. So that's more than half of the loan we've paid back on top of what we've borrowed to the bank. So you can see that when these financial institutions loan you the money, they make a heck of a lot of profit out of every loan they make. Okay, so to answer the question, I've just pasted over some essential parts from the spreadsheet. So I've put in the loan data just to confirm what we're looking at and the relevant loan summary information. So I've just written after 30 years, the amount that we're paying back the bank and the interest paid. I've also popped in a copy of the graph showing you the balance of the loan over time, because I'd like to see the differences that extra repayments, lump sum repayments, or a different interest rate have on the shape of that graph for parts B, C, and D. Okay, part B would like us to see what happens when we make additional repayments of $50 a month. So this is where I enter in $50 into my additional repayment. So you just simply type it in, press enter, and it will adjust the repayment schedule. So you'll notice the difference in the balances over time. What we're really interested in is what happens to the total interest paid, the total payments that we've made now, and this particular row here tells us the total savings we've made over the period of that loan. So you'll notice that we've paid less interest back to the bank. That means we pay less overall, and we make a savings of nearly $16,000. This last section here also tells us the adjusted period that we'll pay the loan off. So instead of paying the loan off in 360 months, we've now paid it off in 334 months, which is 26 months early. So that's just over 2 years we've paid the loan off. So to answer that question, you've made a savings of $15,903.68, and you would finish paying the loan off 26 months early, so 2 years and 2 months. And if we look at the effect on that remaining loan balance graph, you'll see that we've simply paid the loan off earlier, so you get still the exponential shape, but then you get this flat region because you've paid it off before the 360th month. Part C wants us to look at the effect of putting a lump sum repayment of $5,000 made in addition to the regular monthly repayment. So in total, that's going to be $6,210.90. And what we're going to do is we're going to put this in different points of the loan. So we're going to put it in at the 12-month, the 3-year or 36-month, and finally at the 10-year point, so at the 120th repayment. Okay, so to do this, I simply just need to pop in that value into the payment of the relevant period. So we want the 12th month to start with. So $6,210.90. And you'll notice on the graph, you'll see this little dip because that's reducing it so quickly at that point. And after that, obviously, it will adjust the remaining balances, therefore the interest paid, principal paid, etc. And what you'll see in the loan summary is that the total interest now becomes $174,788.92. You've made a total savings of $11,134.44, and you've paid the loan off 13 months early. Okay. To undo this, just press Ctrl Z, or you just grab the cell above it or below it and drag this green square over it and it'll fix it up again. Okay, the next one we want to look at is if it was at 3 years, which is 36 months. Okay, so that's put in. Let's have a look at the effect. You'll notice the dip's a little bit further along on the graph. The total interest paid's been adjusted. You'll notice the total savings is $9,886.80, and we've paid the loan off 12 months earlier. So we've saved less and it's taken us a little bit longer to pay the loan off. Let's move down to changing it to the 120th. So hopefully you remembered to change the payment back at the 36th. Let's change this one. Let's check out what the loan summary says. Okay, so we've paid $179,702.41 interest, which saves us $6,220.94, and we pay the loan off 9 months earlier. You can see the dips move further along the graph as well. Okay, so just summing all of that up, if I was to put in the lump sum repayment at the 12 months, at the 36th month, at the 120th month, what you should notice is that the earlier the lump sum deposit repayment is made, the more you will save and the earlier you will pay the loan off. Okay, for part B, the last thing we need to consider is if we're looking at another financial institution, to compare what happens if we're looking for a lower interest rate. This financial institution is offering 4.08% per annum. We want to look at what the minimum repayments will be for the requirement of the loan. How much would you save by taking on this alternative reducing balance loan? And what if you kept the repayments the same as you were planning to make with the first financial institution in Part B, and show the effect of a lower interest rate and extra repayment? Okay, so the first thing we're going to do is have a look at what happens if we change it to 4.08%. So if we look at that, our repayments drop to $1,205.10. Total interest paid over the period of the 30 years is $183,835. So in total, I pay back the bank $433,835 back to the bank. So if I look at answering the first two parts, repayments of this new loan are $1,205.10. How much would I save by taking on this alternative reducing balance loan? Well, the old loan gave me a total of $435,923.35. This new loan was $433,835. So all up, I'd save $2,088.35. Now, that isn't a huge amount of money over 30 years. So shopping around for a lower interest rate loan does save you some money, but as you can see, not as much money as if you were to make extra repayments or lump sum deposits over the duration of the loan. For part 3, if I wanted to keep the repayments as the same as the original loan I was looking at, that means that I'd look at the difference between the old loan minimum repayments and the new loan minimum repayments, and I'd add on that $50 extra that I was looking at in part B. So to look at the effects of that in the Excel, I'm going to pop $55.80 in additional repayment. So the effects of shopping around for a lower interest loan, as well as making additional repayments, would give me a greater savings, and I'd also pay the loan off a heck of a lot earlier. So just pasting that across, you'll save $17,315.40 over the 30 years and pay the loan off 2 years and 5 months earlier. And you can see the effect on the reducing loan balance graph. Okay, so from all of those adjustments we made to that loan, you should have noticed that increasing repayment amount or making lump sum repayments will decrease the time it takes to repay the loan and also reduce the amount of interest you pay over the period of the loan. And the earlier you make these lump sum repayments or additional repayments, the more money you will save. Shopping around for a lower interest rate may not have as big an effect as making repayments or lump sum repayments. However, this will save you money as well over the period of the loan. What I'd like you to do now is try 3 examples for yourself. So we've got 3 questions here. So have a read through the questions, then press pause and have a go at them. Now this should take you a good half hour to get through these 3 questions. So after you finish having a go, continue on with the video and I'll take you through my solutions to the questions. Okay, press pause and have a go. Okay, how did you go? The first question is a simple familiar question, and we've got our guy Jeff. He's borrowed $50,000 to buy a car and has taken our loan, which charged him 8.2% per annum, compounding monthly over 5 years. The banks requested minimum monthly repayments of $1,018.61. Part A asks you to construct a repayment schedule to show the month repayments, interest paid, principal reduction, and balance over the first 4 months of the loan. Part B wants you to calculate how much interest he's paid in total. And Part C wants you to use the spreadsheet that we've just looked at, set up a complete repayment schedule to verify the details that you've just calculated by hand, state the total amount that Jeff would have to pay back the bank by the end of the loan period, and then lastly state the total interest that he's paid back the bank over the duration of the loan. Okay, so always start off the question by annotating important information, and as a good habit, write down those important bits of information to work with. So our A0 is 50,000, our repayment value, our interest rate, which we've then converted to the rate of interest that you get charged between balances, and our K value. So hopefully your repayment schedule looks something like mine. For part B, we had to calculate how much interest he paid in total after the first 4 months. So the really quick way is just to add up those 4 lots of interest. You could use the total interest formula that we learned last lesson, However, I just quickly added those up to get $1,338.78. For Part C, when I use the spreadsheet, I've just clipped in my entries and outputs. I can see that my calculated repayment schedule matches that of the spreadsheets. To answer Part 2, he'll pay a total of $61,116.74 back to the bank, and of this, $11,116.74 was the interest he's paid back the bank. Alright, let's move on to question 2. This is a combination of simple familiar and complex familiar parts. We have Sally who's borrowed $35,000 from a bank at 5.3% per annum adjusted monthly. The loan's to be repaid in 7 years, and it looks like we've got a repayment schedule extract here with information missing in it. Now this is from her 5th year of repayment, so you can see that it started off at repayment number 56 and finishes on 60th. For Part A, information is missing after a statement got wet, and we've got to fill in the missing information. So we've got to fill in A, B, C, and D. Then for the 61st month, we're going to have to fill out this row here ourselves. And then we have to do all of this by hand using formula. And then for Part C, we're going to go back to using the spreadsheet, work out how much Sally has to repay back to the bank after 7 years. If she makes a lump sum repayment of $5,000 in the 10th repayment, let's determine how much sooner she'll pay off the loan and how much money she would save in interest. And then lastly, considering the conditions of the loan again, determine how much sooner and how much money she would save if she could afford repayments of $600 a month. For Part A, repayments are always the same. So our missing A value is $499.64. For the interest paid, I simply plug in my values into the formula, and for B you should get $56.05. For the principal reduction, remember that's my repayment minus the interest, plug in those values again and I get a C value of $443.59. And to find the balance, I get a D value of $11,353.83. Scrolling down to B, our 61st month would look like this, hopefully. So straight away plug in that repayment amount. Then I would probably work out my balance first by using that recursion formula. I'd then go and work out my interest paid, and finally my principal reduction. For Part C, this is where we're using the spreadsheet again. So I've put in the loan data, so 35,000, 7 years, 5.3%, 12 payments per year. That gives us a payment amount which agrees with what we've been told. When I look at the loan summary, by the end of that loan, she would pay back a total of $41,969.39 by the end of that 7 years. So of that, on top of the $35,000 she borrowed, she's paid interest of $6,969.39 back to the bank. If she was to make a lump sum on top of her regular payment for that 10th repayment, she would pop in $5,499.64. So if I enter that into my spreadsheet, this shows an effect on the loan summary where she would save $1,738.58, and she would also pay the loan off 13 months early, so a year and 1 month earlier. And you can see on the loan balance graph the effect of that lump sum payment on the shape of the graph. Lastly, if we considered the original loan conditions again, and Sally can afford $600 worth of repayments, which is $100.36 more than what she's required to pay. So if I pop that into my additional repayments, you'll see that over the period of the loan, she saved $1,407.64, and she'll pay the loan off 16 months earlier, a year and 4 months earlier. And you can see the effect of that on the shape of the graph. Okay, the last question is a complex, unfamiliar question. This is because you have to make decisions yourself and be able to justify them mathematically. Okay, so we have our friend James, and he's got a choice between two loans when borrowing $450,000 to purchase a house. So with loan A, you can see there's a list of conditions. Same with loan B. So as part of your response, you should be investigating these conditions. In loan A, we're told it's a reduce in balance loan at 3.71% per annum over 25 years. And we have fixed repayments, and he can either choose monthly repayments of $2,303.80, or he could choose to pay it fortnightly with payments of $1,062.76. He is not allowed to make any extra repayments. However, he can make a deposit or one lump sum payment of $10,000 during the first 2 years of the loan. So within loan A, you're testing two different scenarios. If he pays monthly, if he pays fortnightly. And in both those scenarios, you're putting in that $10,000 lump sum. For loan B, this is a reducing balance loan of 4.02% per annum, so higher interest rate, and has minimum monthly repayments of $2,380.24. He is allowed extra repayments, and James thinks he can afford $2,500 per month. However, you cannot make deposits or lump sum payments within the loan. So as the question says, you must provide advice to James about which loan he should choose using the amortisation spreadsheet to help you, and justify all decisions made using mathematical reasoning. Okay, so if we look at loan A first, we know that the earlier you make a lump sum payment, the more we save. So you'd want to make that $10,000 payment in that first month on top of your regular repayment. Once you put all the details into your loan spreadsheet, it should generate the payment of $2,303.80. And what you'll do is we want to put in the $10,000 here. So you'll just add that to the normal repayment. And you can see here that he'll make a total savings of $14,789.75. And he'll pay the loan off 10 months earlier. If we then check the fortnight version, so here we need to change the payments per year to 26. And for this first payment, where we know we must put in the 10,000, because the earlier we do it, the more we save. We just adjust that to include the regular fortnightly repayments. And you'll see here that he would make a total savings of $14,828.73, and would also pay the loan off 23 months earlier. So just within loan A, if he were to choose it, the best choice would be to make fortnightly repayments and a $10,000 lump sum in that first repayment period. Let's look at loan B now. So I've put all of those loan details into the loan data section. On top of that, I've then worked out the fact that he can afford $2,500, and if I subtract his minimum monthly repayment, that means he's making extra monthly repayments of $119.76. So if I put that into the additional repayments section, you'll see that considering all of those loan details now, he would make a total savings of $36,337.28, and he would also pay the loan off 32 months early. So with loan B, he would save a lot more money and pay the loan off earlier. Therefore, I would logically conclude that James would be better off with loan B, and making those extra repayments. All right, so considering everything we've covered in this lesson, the earlier you adjust your loan that you've taken out to include additional repayments, so extra repayments on top of what the bank's telling you to pay, as well as whenever you can put in little lump sums here and there. The earlier you can do them, the better. If you're given the option to make fortnightly repayments instead of monthly repayments, take that option up. And lastly, if you can shop around for a lower interest rate loan, then you'll end up saving a lot of money over the duration of the loan. Take-home messages for this lesson, as you've seen, include the earlier you increase any repayment amounts you make, or if you can make lump sum repayments during a loan, this will not only decrease the time it takes to pay the loan, but also reduce the amount of interest you pay back to the bank over the period of the loan. So you save a heck of a lot more money. If you get the option of making more regular repayments, so you can choose fortnightly instead of monthly, this will also help save you money. And lastly, if you can shop around for a lower interest rate, it may not have as big an effect as making extra repayments or lump sum repayments, but this too will save you money over the period of the loan. Thanks, Year 12s.